from Professor Marty Pietrucha from Penn State. He's a professor of civil engineering and also heads the Pennsylvania Transportation Institute, which does a lot of safety testing and all for school buses, etc. And does over $10 million a year research expenditures. He has a bachelor's degree in civil engineering from New Jersey Institute of Technology, master's from University of California, Berkeley, and a PhD from the University of Maryland.
Lovely. Okay. So yes, as I was thinking about my presentation, I thought, well, you know, I bet we're going to get a lot of background information on this. And I think everything that Dr. White talked about was really important, things that you need to know, particularly if you don't have a big background in the logistics or the supply chain area. And so he's given you a lot of information about what we need to think about and the kinds of things that we're going to talk about as we try to move forward and come up with some ideas about this. And I thought what I'd do is maybe talk a little bit about how we might think about some of these problems and give us a little bit of a different approach on things. And rather than giving a straight presentation, I thought I'd tell a couple of stories because number one, I'm a really good storyteller. And number two, I think people like stories better than they like presentations. And you know, this is sort of borne out by the popularity of the receptions and other things that you see at professional meetings. So think of this like the reception just starting early, because I knew I'd be standing between you and the reception. So the reception's starting now. You just don't have any drinks available to you, and you know, there's nothing I can do about that. So I thought we'd talk about a few little points to ponder, or well, this isn't going to be as easy as we think, okay? And but is it ever, right? Isn't this how things turn out all the time? So the Larson Institute, which is getting clipped off in the corner there, its full name is the Thomas D. Larson Pennsylvania Transportation Institute. It's a multidisciplinary institute at Penn State covering all things related to research, education, and outreach in the transportation field. And this is a little word cloud that comes off of our main page of our web, and so sort of the sort of things that you would expect to see with something like this. We're involved pretty much in the full spectrum of things that you would expect in the transportation area. So we do things related to infrastructure. We have a whole host of programs and centers that are part of the Institute, and they have the sort of standard sounding names that you'd expect in something like that. So we have a transportation infrastructure program. It's all the people who deal with bridges and water and subsurface conditions and pavements, okay? We have another group that's our vehicle systems and safety group, okay? All the mechanical engineers, and they deal with things like pavement tire interaction, all the way from there up into the vehicle, design of the engine, the power plant, vehicle dynamics, crash dynamics, those sorts of things. We have a third program that's called the Transportation Operations Program, and that's everything else. So then that was the program I used to be the head of before I became the Institute director, but that covers things like policy, funding and financing, transport economics, supply chain, standard planning, design, and operational issues for the transportation system, human factors, which is my area of scholarship, and I've been working in for the past 37 years at this point. So, but in as much as we're sort of viewed as experts by a lot of people in the industry, and we do a lot of work with the trucking and bus industries, we have quite a bit of expertise related to heavy vehicles. As Dr. White pointed out, and I think it was really nice, you know, it's almost as if we talked about this. You really teed this up for me. We get a lot of inquiries from people in the industry about what can we do to be more fuel efficient with the trucks that we run, because the trucking industry itself runs on pretty small margins. And so when there's a significant change in the diesel fuel cost, this sends repercussions through the industry. All right, so when we had those high rates of diesel fuel a couple of summers ago, this was really causing some great consternation within the trucking industry. And so we get asked about this quite a bit. So it made me think of, you know, several years ago, for those of you who are old enough to remember, Volkswagen used to have a very sort of interesting ad campaign in the 60s, sort of making you think about things a little obliquely rather than the way that you might think about them. And so here it was, the 84 mile per gallon Volkswagen, and I think it gets back to a lot of the issues that Dr. White was talking about. How do you make things more fuel efficient? Well, you can make them way less. Well, that's not going to work very well in the trucking industry. You can make them better from an aerodynamic standpoint, okay? Or you can decrease rolling resistance, all right, by having a different design to the wheel that you roll on, okay? So the reason why Norfolk Southern and the other railroad companies can say, we can take 1 ton of freight and move it 436 miles on 1 gallon of fuel is because the rolling resistance is so low when you have steel wheels on steel rail, okay? Nice hard wheel, nice hard surface, really low rolling resistance, right? Makes a great deal of sense. So here's the truck tire. The truck tire we all know and love, the ones that we've been seeing for years and years and years. And Dr. White points out that, well, you know, they're not really looking like that anymore. They're starting to look more like this, almost more like that bicycle tire, okay? And this does great things for the rolling resistance and can actually increase the fuel efficiency of the truck. So the mechanical engineers at the Institute are consequently very happy when they come up with something like this. But the civil engineers, they come back and they're not happy about this at all because this creates greater rutting in the roadways. Okay, so when you get that nice warm asphalt in the summer, heavy trucks loaded as best we can with a safe stack system on a nice, really hard tire, it starts to wreak havoc with the pavement. So this is not good. This starts to beat up the roads, and we're already having a funding and financing crisis with infrastructure in the country. Can we really afford to help out the trucking industry to the detriment of the infrastructure? So there's going to need to be some sort of discussion relative to that. So again, it's not as simple as we think. We change things in one place, we're going to have things changing in a different sort of place. And just a rough rule of thumb, when you get one truck passing over the roadway, it's equivalent to about 2,000 automobile passes in the amount of damage it does to the pavement. Okay? And so increased size and weight is a good thing. I think generally it's been discussed by many different parts of the logistics industry, but the infrastructure people are really going to put up a really serious fight before we're allowed to change that. One of the other constraints that many don't know about is something called the AASHTO bridge formula. The American Association of State Highway and Transportation Officials has a formula for bridges in terms of truck weights and the fatigue that sort of the bridges are subjected to by the number of heavy trucks and multiple heavy trucks on the bridges at the same time, and it has to do with axles and wheelbase and a whole host of other things. So again, it won't be just as simple as saying, here's the way to shortcut things and have greater efficiencies. It's going to be part of this larger system of systems discussion that I think several of the speakers have already mentioned today. Okay. Excuse me, was that me? Every year up at Penn State, our supply chain program, which is consistently one of the top 5 academic programs in supply chains, along with industrial and manufacturing engineering at Penn State, I might add. They have a conference. The Center for Supply Chain Research has this conference, the R. Hadley Waters Supply Chain Symposium. Great symposium. I go to it whenever I'm in town. I have to travel quite a bit, but I've made it to a number of these over the years. It's always great to go to any kind of a meeting that's not in the field that you're in. You stand to learn a lot more than if you go to meetings about the field that you're involved with directly. So I usually go to the Waters meeting, and it's a great place for me to learn things. So a couple of years ago, there was a representative there from Crown Holdings, Crown having a headquarters in the Philadelphia region, and these folks are one of the world's largest manufacturer of steel and aluminum cans. Okay, and so you folks are familiar with those, I think, right? They're everywhere. They're everywhere. Well, years ago, they got involved in a deal with the people who make these products, okay, Coca-Cola. And so Coke did not want to have to spend money on warehousing in their bottling plants to be able to have, it's funny they still call those bottling plants, right? But nonetheless, they do. The industry is still that they call those bottling plants. But they didn't want to take up the space in their bottling plants to have this large inventory of cans to be able to bottle their soda products when they came off the line once they were actually produced. And so they had a deal with Crown, and they said, you'll deliver the cans we need to be able to bottle a run of soda within the end of the production plus or minus 15 minutes. Okay? Pretty tight constraint. And the deal was that if Crown didn't make it within that window, they bought the soda. okay? So they needed a really big glass whenever they messed this up. But they were going to buy the soda, all right? So me, being a traffic engineer in a past life, said, wow, that's pretty amazing. You know, are these things all done at night? How do they get through the network, right? Here's a little condition diagram. That was New York yesterday morning about 10 a.m. Okay, I wanted to throw in something that was kind of current. And so I asked the fellow, I said, gee, you know, how often did you miss a run on that? And he said, well, about 1% of the time. And I said, well, that's pretty good. You know, pretty decent reliability there. I said, how many of these deliveries were you making? And he said, 14,000. And that was just in the middle Atlantic, okay? So 14,000. They had 140 of these things that they missed. But again, I thought that level of performance was phenomenal. And I said, so were you working very closely with PennDOT in the Pennsylvania region or the Delaware Valley Regional Planning Commission or anybody like that in order to be able to do some sort of front-end planning about how to do any of this? And he said, no. He said, we do this not because of anything you're doing. We do it in spite of what you're doing. So there isn't really very close coordination, despite the fact that if you talk to PennDOT, they have a deputate. There's a deputy secretary that is involved with freight issues. He's also involved with transit issues and airports and a few other things, okay? And if you go to DVRPC's website, they have a strategic freight plan. They're holding discussions with all the different stakeholders in the freight industry, the shippers, the carriers. But a lot of what gets done is related to the improvement of one choke point within that larger network. All right? I'll just let you read that. You can read. I don't need to read that. So we're coming together and trying to figure out what to do. But when you get the experts together in the field, they can't even agree about what to do. All right, so how do we start to attack this problem? Well, fortunately, this was the front end of the research they were doing on this, and this resulted in a report from the National Cooperative Highway Research Program, which is part of the Transportation Research Board, which is part of the National Research Council, which is part of the National Academy setup. Okay? And they found they had some real success using scenario planning for transportation planning. So now it comes back around again full circle to this whole idea of systems, right? We can't do things in a vacuum. We need to be thinking all the time about where do the inputs and outputs for our little slice of the business begin and end, and how do those affect the inputs and outputs for all the other things within the system. So that's it. I'm going to be short and sweet. I want to save some time. I think we'll get a lot more out of the discussion on this. I always learn more from you folks than you guys will learn from me, and that's one of the reasons why I'm here. So, thank you.